Hello everyone, I'm Antonis Andronikakis, Communications Manager at reframe.food. Welcome to our Smart Droplets project podcast series. Smart Droplets focuses on reducing pesticide and fertilizer use by integrating advanced technologies. It does so by using a holistic approach, combining various technologies. Today we have our partners from Vizlore Labs from Serbia, Milenko, Tosic and Mihailo Ilic, to talk us about some of these technologies and particularly the role of IoT. We will start our discussion with Milenko. So Milenko, welcome to our podcast series.
Antonis.
I would like you to introduce yourself and of course tell us about VLF and its role in the project.
Sure thing. So it's really a pleasure to be here recording this podcast. And first of all, let me start with introducing the Vizlore Labs. We are a research organization, non-for-profit research organization from Novi Sad, Serbia. We specialize in application of Internet of Things, artificial intelligence, and blockchain technologies in different domains, including agri-food, energy, water management, smart buildings, etc. We are very active in European-funded research and innovation projects. And within these projects, we usually take on the role of a partner who is responsible for implementing data management practices with focus on interoperability and also establishing different intelligence based on the collected data. I myself am an IT engineer with 14 years experience in the field, and from the start of my career I have been developing and integrating different IoT solutions, enablers and applications. And also lately I'm quite active in developing scalable data management platforms with focus again on interoperability. Within the Smart Droplets project, Vizlore Labs is responsible for implementing the data management platform, which is part of the overall Smart Droplets digital platform. More specifically, we are in between field systems as primary source of information and the actions and the AI and digital twin based logic on the north side of the solution.
With all these activities and your expertise, can you explain what IoT or the so-called Internet of Things is and how it's being used in the Smart Droplets project?
Of course. So the Internet of Things basically entails application of different technologies which were initially developed for data exchange between computer systems, and now applying those technologies between different systems and things from the physical world. It enables machine-to-machine, digital system-to-machine, and human-to-machine communication and interactions. The main application of the Internet of Things is different automation processing approaches. There are usually three different steps within this automation, starting with the smart sensing, where different sensors deployed in the physical world collect information about the processes and the states. We have the process of analyzing the collected data to make informed decisions, and basically performing smart actuations, or translating the smart decisions into the actual actions within the physical world. There's also a process of iteratively learning from the past runs of the solution. Within Smart Droplet projects, we are implementing an IoT system for smart application of pesticides and fertilizers in the fields. This IoT system encompasses, first of all, the autonomous field system, which is in fact a retrofitted tractor equipped with different IoT systems for computer vision, for navigation and autonomous driving, and smart spraying, all of those brought by different consortium partners. We also have the AI digital twin based decision making logic and the data management platform in between these two systems.
So you've basically developed an IoT system which helps farmers make decisions. Let's dig deeper into this technology. I would like you to please tell us how does data collection work in the context of Smart Droplets and what types of data are being collected from the fields?
Of course. So data collection within the Smart Droplet project can be performed in four different ways. First, with our IoT system, which I have just briefly described. All the smart sensing capabilities of the Smart Droplets field system are generating different data points that help us understand what's happening within the fields and what the state of the crops. This data, for example, includes computer vision information about the state of the observed crops, either any detected deficiencies or the diseases, information about tractor navigation and its overall state, pesticide and fertilizer application logs as performed by the autonomous system itself, and different environmental sensing data collected by the system. Second, we utilize third-party data sources like weather forecasting, satellite imaging, and databases about the crops and pesticides. For the third data source, we are relying on the legacy data sets from the farmers and farms themselves, and also from the digital systems that the project partners are bringing to the project. Within these legacy data sets is really a vast knowledge about past actions and reactions, how systems behave in different setups, how crops perform in different conditions, and what are effects of various pesticides and fertilizer application on the crops, their yield, and suppressing the diseases. Finally, we rely on certain manual interventions by the farmers themselves. We provide them with different interfaces for them to provide information about the crops, the fields, and the actions they are taking beside the one that the autonomous system is capable of doing. We from Vizlore Labs know that it is very important to properly model all the mentioned data points and make them work together, basically make them interoperable. We strongly believe that valuable data is the data that can be shared with other stakeholders in the system. So only by sharing the data and the information and federating the knowledge from different farming systems, we can really strive towards the truly smart farming solutions.
I see, Milenko. Lots of useful data for the farmers and lots of challenges. And also thank you for mentioning the importance of interoperability and your role in the project. So having said that, I would like to thank you for being with us. And shortly we will welcome Mihailo. So have a nice day, Milenko, and thank you for being with us. And now I'm welcoming Mihailo Ilic, and we will continue our interview with Mihailo. So, Mihailo, welcome. We're glad to have you here to continue our interesting conversation.
Thank you for having me. Just to briefly introduce myself, I'm also a research software engineer working on the Smart Droplets project here alongside Milenko at the Vizlore Labs Foundation.
So, we were talking about data, and we will continue in this topic. I would like to ask you, Mihailo, how does IoT and data collection actually improve farming practices, and what are the main benefits for farmers using these technologies?
Okay. Well, the main goal of smart farming is to improve the efficiency of all processes which are involved, which in turn increases the yield that we can get and the profits that we can expect. So the typically manual work and legacy processes, which are done by farmers themselves, have reached their peak in terms of efficiency. Today, everything seems to be about data, collecting data during every step of the process, and asking the question, how can we improve the entire process and what do we need to change? What makes farming smart today is real-time monitoring. A common phrase that you can hear from data scientists is that you can never have enough data. If we can be more efficient when irrigating, when applying pesticides, when harvesting, and so on and so forth, we can have a significant and positive impact on the environment and also on energy efficiency. Data collection is the main driving force behind all of this, and data analytics can help us identify inefficiencies in our current systems and workflows. These terms of data analytics and data collection are also the building blocks for autonomous agricultural systems, which we aim to empower with the Smart Droplets project.
So, lots of benefits, lots of good things in store for farmers, but I would like to ask you, what do you think farmers are thinking about the adoption of IoT and smart farming solutions? And you've mentioned the benefits, but are there any obstacles or shortcomings for this procedure?
Yes, well, definitely. I think that farmers are generally aware of the numerous benefits that IoT and tech can generally bring to their day-to-day activities, right? These benefits include increased efficiency, better decision-making, help in resource management, predictive analytics, and crop monitoring, right? On the other hand, we also have perceived and real challenges when it comes to implementing IoT in agriculture. Some of the obstacles include the cost of implementation, technical complexity of the systems, data privacy and security issues, since we're handling a lot of data, interoperability, which is one of the main focuses of the Smart Droplets project, connectivity issues, and much more, right? Apart from these, there are also some perceived risks, like the accuracy of the data being collected. Are these systems scalable or not? Is it possible to integrate new systems with already existing systems? All of these are valid concerns. However, with the right approach and with enough planning, they become a lot less scary, right?
Mm-hmm. Thanks for giving us a so clear, let's say, image of the landscape in IoT and its adoption. I have a broader question. I would like to ask you, what are the main challenges in general for the IoT and digital technologies in the agri-food sector?
Yeah, certainly. Yeah. There are barriers for adoption of digital technologies in all domains, and not just in agriculture, right? Our specific challenge right now is to balance between bringing disruptive technologies and to support already existing process and streamlining it, right? We don't want to come today and tell the farmers that from tomorrow you are going to be doing everything differently, since this is going to scare the farmers off from using such solutions. There's also a need for keeping humans in the loop, since farmers would like to automate the boring and the repetitive stuff, but they still would like to have full control over the final decision making. This is why we are still so far off from full automation, since these kinds of systems need time to build up trust in the eyes of farmers. There's also an issue of responsibility for fully autonomous systems, right? If I have an AI algorithm and it makes a bad call and ruins my crops, who is going to be responsible for this? A good and easy example always is autonomous driving. If you're driving down the road in a self-driving car and it misclassifies a white truck as a white cloud, that's going to cause an accident. This is, of course, a 1 in a million occurrence. However, you don't want it happening to you in any case. This also applies to agriculture, since a bad decision by the AI can ruin your crops for the year and your livelihood. Another major barrier is interoperability in the domain. This is true for a lot of industries, mostly in agriculture this holds as well. Some solutions may not be compatible with other solutions, and this can be a major barrier when adopting new technology, since you may be too reliant on what you already have. Apart from this, a big deal is also privacy and security of data, which is a major concern in any system dealing with large amounts of data. Because of this, these systems need to be completely bulletproof, meaning that they don't need to only minimize the risk of data leaks, they need to completely eliminate any sort of risk of this happening.
Okay, that's a great answer. I think that you've listed all the probable threats, let's say, and the improvements that are still needed in the domain of IoT and digital technologies in farming. What I'm understanding from your answer is that farmers don't need completely disruptive technologies, but they need friendly technologies, safe technologies, and technologies that will enhance their practices. So I want to also thank you, Mihailo, for being with us. It was a great interview, and probably you will be joining us for another episode.
Yeah. Thank you as well. It was a fun experience, and I hope that there will be more chances for conversations like this.
Thank you, Mihailo. And to our viewers, thank you for joining us today. Don't forget to follow our social media accounts and our YouTube channel. Stay smart.